So today we're going to take the next step. Last class we looked at operations with those whole numbers, adding, subtracting, multiplying, dividing. Today we're going to look at what happens when we run into something like this, -4. To deal with that, we need to get a little bit into number theory. For today, we're only going to be talking about the amounts, the counts. We're not going to worry about the labels or the names. When we're dealing with these amounts, the most common graphical representation of the size of a number, the amount of a number, is on a number line. And most of us have seen dots put on the number line to represent a number, which it does. I mean, I could put a dot here at -4, and that would represent -4. But a more useful representation, a mechanical representation, is using what we call vectors. And you don't need to know that word. It's just a fancy word for a real simple concept. All it is an arrow that starts at 0 and goes to that number. So that is the vector for -4. So the vector for 7 would look like that. There's the vector for 7. So let's say I gave you the problem 7 plus 2. Well, we have the vector for 7. Here's the vector for 2. Addition is nothing more than a process of combining the vectors. So we would take this vector and combine it with that vector, and we can see that it ends up at 9. So 7 plus 2 is 9. And you guys all knew that, hopefully, right? Well, then what would happen if we did 7 plus a -4? In your book, you'd probably put parentheses around the -4 just to separate it. So we've got the vector for 7. We have the vector here for -4. Combining those, just like before, only since they go in opposite directions, they don't build up to make a longer one. They cancel out to make a shorter one. We end up at 3. 7 plus -4 is 3. Now, I don't expect you to draw out number lines every time you deal with negative numbers. But having that picture, I actually keep that picture in my head as I'm working with them to help me figure out what to do. Because there's really only two things that can happen. We saw, when we had like 8 plus 5. If here's 0, 8 is there, 5 is there. They're both positive. They both go in, first of all, that tells us the answer has to be positive. And they both go in the same direction, so we're going to add the amounts. 8 and 5 make 13. Or we could also have -7 plus -3. Again, your book would put parentheses around the second one to separate it from the plus sign. Well, if here's 0, here's -7, and here's -3. Again, they both go in the same direction. This picture is showing us that the answer is negative because we're on the negative side of 0. And since they both go in the same direction, we're just going to add the values. 7 and 3 make 10, so we get -10. So that's one possibility. Both of them go in the same, both vectors go in the same direction. So we just add the values together. And we know whether they're going positive or negative just by looking at it. The other possibility would look like our example up there. We might have 9 plus a -5. So here's 0. There's 9. But -5 goes the opposite direction. Now we have to ask, is -5 going to be longer or shorter than the 9? Shorter. But it does go the opposite direction. So that picture tells us that we're on the positive side of 0. Since the vectors go opposite directions, it's the difference between the values. What's the difference between 9 and 5? 4. So that answer is +4. We might have -7 plus 11. So here's 0. -7 goes this way. +11 goes the other way, longer or shorter? It's longer. So it actually goes past 0, telling us that we made it to the positive side of 0. And again, the vectors go opposite directions, so it's the difference between 7 and 11, which is 4 again. So we might have -13 plus 2. Well, here's 0. -13, +2 is obviously shorter. So what's the answer going to be? Positive or negative? Bless you. Negative. And 11. It's the difference between them because they go opposite directions. 5 plus negative 8. So here's 0. We got positive 5, negative 8, longer or shorter? Longer. So the answer is negative, because we're on the negative side of 0. The difference between 5 and 8 is 3. Make sense? Like I said, I don't expect you to draw the number line, but just having that little picture there helps. It helps me get into larger numbers as well. 238 plus a negative 104. Well, here's 0. There's 238. Negative 104 is going to be shorter. So that tells me, first of all, we're positive, and it's the difference between 238 and 104. So 238 minus 104 is 134. So positive 134. Simple enough? Okay. Subtraction is where it gets to be tricky. Partly because most of what you've been told about subtraction throughout your whole life is not necessarily true. Well, in so many ways it is, but mathematically, subtraction has been a lie. Let's put this on there. 8 minus 3. Well, it would be pretty easy to say this is 8. And then minus 3 would just go back to 5, like that. Because we know that 8 minus 3 has to be 5. But as we look at this picture over here, oops, that's what I wanted. If we look at this picture over here, we see it looks an awful lot like the same picture we would draw for 8 plus a negative 3. In fact, it is exactly the same picture we would draw. The reason it's the same picture is because they are the same problem. Subtraction does not exist. We talked a little bit yesterday about subtraction and addition being the same operation, just one's forward, one's reversed. Well, that's truer than you would think. Subtraction is a form of addition. It's a shortcut. This symbol right here that we know as the subtraction symbol means add the opposite. By opposite, I mean if it's positive, the opposite would be negative. If it's negative, the opposite would be positive. So 8 minus 3, what this is saying, subtracting 3 is saying add the opposite of 3. Instead of adding 8 to 3, you're going to take 8 plus a negative 3. You're adding the opposite of positive 3, which would be negative 3. So that's why 8 minus 3 and 8 plus a negative 3 are the same problem. So if we see 7 minus 12, what that's really telling us to do is take 7 plus a negative 12. So here's 0. There's 7. Negative 12 is longer. That's going to be a negative 5. Or if we have negative 3 minus 8, that becomes negative 3 plus a negative 8. Here's 0. There's negative 3. Negative 8 goes the same direction. This is a negative 11. Or we might have a negative 4 minus negative 7. This is the one where it gets really tricky. Minus a negative. Well, the negative 4 doesn't change. That first number never changes. This is saying to change this to addition and make the opposite. What's the opposite of negative 7? Positive 7. So negative 4 minus a negative 7 is negative 4 plus 7. So there's 0, there's negative 4, there's positive 7. So this is going to be a positive 3. That's the one that usually gets people, subtracting a negative. So let's say we have 2 minus a negative 8. What's that going to become? 2 plus a positive 8. That one we can do pretty simply, 10. What do you think? Better than a sharp stick in the eye? Okay. So that's addition and subtraction. Multiplication. When we first learned to multiply, we went over this a little bit in last class. 5 times 3, of course, we were taught is repeated addition. That's saying 3 5s added together to get 15. Because of that, it's not much of a stretch then to look at negative 5 times 3, which is just 3 negative 5s added together, which would be negative 15. What about 5 times a negative 3? Well, we can't take negative 3 5s and add them together, can we? So we have to think of this a different way. We can switch it to be negative 3 times 5, so there's 5 negative 3s added together, which would give us, well, excuse me, still negative 15. The real showstopper is this one. Negative 5 times negative 3. We've all been taught that you multiply a negative times a negative, it's a positive. It's a positive 15. But if you look at the definition of multiplication, that definition of repeated addition, I can't take a negative 3 negative 5s and add them together. And I can't take negative 5 of the negative 3s and add them together. So according to the definition of multiplication, this can't be done. And this happens in math a lot, where we run into stuff where the definition breaks down and it doesn't work. So what we do is we look for a pattern and we just define the result to be whatever fits that pattern. So for this one, we said negative 5 times positive 3 was a negative 15. What would be negative 5 times positive 2? Negative 10. Negative 5 times 1, negative 5. Now let's look at this for a second. Here, as long as we're starting with negative 5 every time, if we reduce what we're multiplying by 1, the answer goes up by 5, from negative 15 up to negative 10, from negative 10 up to negative 5. So if this is true, that pattern would continue. What's negative 5 times 0? 0. Well, this went down by 1. Did this go up by 5? Sure did. So that pattern looks to be valid. So negative 5 times a negative 1, it'd have to go up by 5 more, positive 5. Negative 5 times a negative 2 would have to go up by 5 more, positive 10, and so on. Well, it's just in math, sometimes our definitions break down, so we define the result to be whatever fits the pattern of the other numbers. Math is about patterns. You guys haven't seen me do a lot of it yet, but I can calculate pretty well in my head. It's not that I am that quick at calculating, and it's not that I have a whole bunch of stuff memorized. It's that math is about patterns, and once you see those patterns, it's easy to calculate. Yes, sir?
Rick told me to ask you, how you get 0 when you add 1.
So, now that we've seen the multiplication, if we have negative 7 times 9, what are we going to get? Well, first of all, is this going to be positive or negative? Negative times a positive will be a negative. And 7 times 9 is 63. 11 times a negative 4. Positive or negative? Negative. Good, because there's one of each. One positive and one negative when we're multiplying will always be negative. 11 times 4? 44. So multiplying the numbers doesn't change. All you have to do is figure out whether the answer is positive or negative. Negative 8 times negative 3, positive or negative? Positive, and it's 24. Division? Well, division actually isn't so bad. Remember, division, we talked about addition not being its own operation, or subtraction not being its own operation, that it's a byproduct. You can come in and have a seat. That it's not you're early yet. Subtraction is just a byproduct of addition. Well, same with division. Division is a byproduct of multiplication. When we are told that 24 divided by 8 equals, when we're asked that question, 24 divided by 8 equals what? What it really is talking about is what times 8 equals 24. Well, what number would you fill in here? 3. 3 times 8 is 24. So 24 divided by 8 equals 3. Well, when we throw in the negatives, it's the same thing. 36 divided by negative 4 equals what? Well, that's saying what times negative 4 would equal 36. Well, 36 is positive, so in order to get a positive answer, I have to have a negative times another negative. And then, of course, it'd be 9 times 4. So this has to be a negative 9. So just like multiplication, a positive divided by a negative is a negative. One positive, one negative. What if it were in the other order? What if this were 28 divided by, a negative 28 divided by 7? Well, that's saying what times 7 equals a negative 28? Yeah, since this answer is negative, I have to have a negative times a positive, so this would be a negative 4. So again, a negative divided by a positive is a negative. So just like multiplication, if I am dividing one positive and one negative, my answer is going to be negative. I have a negative 33 divided by a negative 3. Well, again, what times negative 3 would be a negative 33? Well, this is negative. What would I, to multiply to get a negative times a positive. This is going to be a positive number, positive 11. So again, just like multiplication, if I divide two negatives, the answer ends up being positive. Not so bad? No, it's not. It's really, it's for different reasons, but it's the same rule as for multiplication. Now, we looked a little bit at this operation. We'll look at it more as time goes on. What does that mean? 8 squared. And of course, to calculate it, it's 8 times 8, right? Or 64. If we have a negative 7 squared, you have to be very careful. If you punch that in just like that into many of your calculators, it's going to try to tell you negative 49. That is not true. Anything squared, negative 7 squared is negative 7 times negative 7, right? A negative times a negative should be positive 49. What's happening on your calculator is your calculator is doing something called order of operations. When you punch it in like this, it's squaring the 7 first and then applying the negative. So in your calculator, when you square a negative, you have to put it in parentheses, like that, negative 7 in parentheses, and then hit the x squared or power of 2 key, and it'll give you the positive 49. We'll talk about those more later. Does yours do the same thing? Yep. That's, I'd say, about 2/3 of the calculators out there. You have to make sure it's in parentheses. Now, out of your book, we're skipping around a little bit here, but I wanted to get the negatives done early in the semester. On page 111, 1 through 39, the odds. And page 114, 1 through 35, the odds. And then that's your addition and subtraction. Your multiplication and division are on page 116, 1 through 39, and 51 through 79, the odds. I know that's a lot of problems, but these are kind of easy. And like I said before, if you do the first couple and they seem easy, skip ahead 5 or 6 and do some more difficult ones and go that way. And then I won't see you guys again until Monday, will I? No. So have a good weekend.
I can't get